This is Unit 5, Video 12, Stoichiometry, gram to mole. We're going to do some more stoichiometry examples. Now we're going to bring grams into play because we measure grams. That's how we figure out how many particles are present, is by measuring the mass of the reactant or the product produced, either one. So let's go through. We've got our reaction. This is phosphorus reacted with fluorine, producing PF3, phosphorus trifluoride. We have it balanced. Got to be balanced. You cannot do stoichiometry without a balanced reaction. Okay? We want to know how many moles of PF3 are produced when 10 grams of fluorine reacts with excess phosphorus. So there's plenty of phosphorus, so don't have to worry about it. We've got 10 grams of fluorine. We want to know the moles of PF3. So let's just highlight these here. So this is what I'm trying to find, moles of PF3, and this is what I have right here, 10 grams of fluorine. Obviously, this is important for the chemistry, not really for the calculation. So the statement in excess phosphorus is important, but it's not important to the actual calculation. So let's go through and do the calculation here. We've got, here's green, we've got 10 grams of fluorine. Okay, we're going to convert that to moles. We're never going to do stoichiometry without moles, okay? Because this balanced reaction is 2 moles of phosphorus, 3 moles of fluorine. So we're going to go through, and fluorine is a diatomic, so we have 38 grams in 1 mole. And I'm going to go ahead and write down the individual values. Later on, we might not do that. I'm going to have 0.175, no, 0.263. 0.263 moles of fluorine. So now I know the number of moles of fluorine. This tells me how many fluorine particles are reacting. It's obvious the reaction's happening, a phosphorus atom hitting a fluorine atom and then combining in that form. So now I want to set up my mole ratio so that I can go to PF3. Moles of F2 on the bottom, moles of PF3 on top. Okay, from the balanced reaction. I have a 2 here, I have a 3 here. So I'm going to have 2/3 of 0.263. That's 0.175. So 0.175 moles of PF3 are produced if 10 grams of fluorine completely reacts. Okay, all right, let's do one more. What mass of fluorine would be produced or used, since it's a reactant, would be used to produce 3.5 moles of PF3. Kind of going the reverse of the previous thing. So let's highlight what we have here. We're trying to find the mass of F2. Right there. That's what we're trying to find. And our given is 3.5 moles of PF3. Again, this is important for the chemistry, not really for the calculation. We have to have phosphorus there. The reaction can't proceed. So we're not going to make phosphorus out of thin air. Okay, so let's do our calculation here. We've got 3.5 moles of PF3. So 3.50 moles of PF3. I'm trying to find fluorine. I have PF3. I'm going to go to my balanced reaction. The relationship is 2 to 3. PF3 on the bottom. And PF3 has a 2, F2 on top, it has a 3. Notice, last time the ratio was 2/3, now the ratio is 3/2. There's no rule that one thing goes on the bottom versus the other than what you have goes to the bottom, what you want on top. We can always work backwards, because I could be in a factory and say I need to produce 2 tons of aspirin. How much of the reactants do I need to buy to make that reaction occur? Very valid calculation in chemistry. All right, now I'm going to go through and I'm going to, I can solve right there, and that will give me the moles. That's 5.25 moles. But the problem wanted the mass of fluorine. We have moles. We know how to make this conversion. 38 grams for every mole of F2. And that's going to give us the final mass, which is 199.5 grams of fluorine. Now you can see here we had 3 significant figures in our original, and now we have 4 significant figures, so we're going to round that up. When we do, we're going to get 200. Very hard to represent that number in 3 significant figures, so it'd be 2.00 times 10 to the second grams of fluorine.